Pluto. Reimagined. The James Webb Space Telescope, humanity's sharpest eye in the cosmos, has completely transformed our view of Pluto and its role in the outer reaches of the solar system. For much of the 20th century, Pluto was little more than a mysterious speck on astronomical charts, a frozen remnant of solar system formation, drifting at the edge of the Kuiper belt. It was thought to be too small, too far from the Sun, too cold, and too geologically inactive to matter. When it was reclassified in 2006 and stripped of its planetary status, many believed Pluto's story had ended. To them, it was little more than a relic, circling quietly in the darkness. But Webb's extraordinary infrared vision has shattered that picture. Pluto is no longer just a silent, frozen body. It has emerged as a surprisingly complex, dynamic world, alive with activity beneath its icy surface. A hidden ocean? One of Pluto's most intriguing features is its iconic, heart-shaped basin known as Sputnik Planitia. For decades, scientists believed it was nothing more than a smooth expanse of frozen nitrogen. But Webb's data suggests something far more dramatic may lie below, a vast, hidden ocean, kept liquid by insulation and heat from Pluto's rocky core. If true, this would mean liquid water, one of the essential ingredients for life, exists at the frozen edge of the solar system. The possibility of microbial ecosystems beneath Pluto's crust has sparked renewed debates in astrobiology. What was once considered impossible, life flourishing so far from the Sun, now feels like a question we can actually test. Geological surprises. Pluto's surface tells a story of constant renewal. Towering mountains of solid water ice, harder than steel in such frigid conditions, rise to Himalayan heights. Smooth plains, almost free of craters, hint at recent resurfacing. Even now, Pluto appears to be reshaping itself. Deep below, radioactive elements in Pluto's core produce heat. That heat drives convection, allowing nitrogen ice to flow slowly across its surface like glaciers of another world. Instead of being geologically dead, Pluto is alive with change, far more active than anyone expected. Pluto and Charon. A binary world. Pluto's story is incomplete without Charon, its largest moon. Unlike typical planet-moon systems, Pluto and Charon orbit a common center of gravity and space, making them a true binary system, the only one of its kind in our solar system. This gravitational dance pulls on their interiors, creating tidal forces that stir their cores. Charon's rugged canyons and ridges bear the scars of this tug-of-war. Its reddish tint likely comes from gases escaping Pluto's atmosphere and settling on its surface. Some evidence even hints that material is exchanged between the two, enriching both worlds with organics and ices. A breathing atmosphere. Pluto's thin atmosphere, composed mostly of nitrogen with traces of methane and carbon dioxide, behaves unlike any other. As Pluto swings through its elongated orbit, its atmosphere breathes. When closer to the Sun, surface ice turns directly into gas, swelling the atmosphere. As Pluto drifts farther away, that same atmosphere collapses back, freezing onto the ground as frost. Floating within this fragile shell are complex organic molecules known as tholins. These strange, reddish compounds, formed when sunlight interacts with methane, stain both Pluto and Charon with alien colors. But tholins may represent more than pigments. Some scientists believe they are precursors to life, early steps in the chemistry that could eventually build biology. If tholins reach Pluto's hidden ocean, mixing with liquid water and heat, they could spark entirely new forms of chemistry, and perhaps, biology. Life at the edge? On Earth, life has shown remarkable resilience, flourishing in places once thought impossible. In the crushing darkness of the ocean floor, where sunlight never reaches, entire ecosystems survive on chemical energy alone, thriving around hydrothermal vents powered by heat and minerals. These discoveries forced us to rethink what life truly needs. Now imagine Pluto. Beneath its icy crust, a hidden ocean may be sealed away, insulated from the frozen void above. If heat from Pluto's core and chemical nutrients mix within that ocean, conditions could resemble those extreme habitats on Earth. Could microscopic organisms survive there, drawing energy from chemistry instead of sunlight? Could they form colonies around hydrothermal-like vents in alien waters? Or might life on Pluto be something entirely unfamiliar, creatures shaped by pressures, chemistry, and temperatures unlike anything on Earth? The possibility is staggering. If life can exist so far from the Sun, it would suggest that the universe may be filled with habitats where biology can take root. Worlds we once dismissed as barren suddenly transformed into potential oases. Future exploration could unlock these mysteries. Spacecraft orbiting Pluto could chart its surface with precision, revealing fractures and heat signatures that hint at an ocean below. Landers might one day drill through kilometers of ice to search for organics. And perhaps, in a far-off future, robotic submarines could descend into Pluto's secret waters, recording the first images of an alien ocean. The engineering challenges are immense, but the reward, the discovery of life beyond Earth, would redefine humanity's place in the cosmos. The broader picture, even though Pluto lacks a strong magnetic field, it has a curious relationship with the solar wind. Streams of charged particles escape its surface, rising into space in delicate patterns, shimmering faintly through its fragile atmosphere. The James Webb Space Telescope has revealed this dance in detail, capturing interactions that were invisible before. These observations extend beyond Pluto itself. They offer vital clues about the Kuiper Belt, the vast expanse of icy worlds orbiting beyond Neptune. Pluto is just one among thousands of these bodies, but it has become our window into this mysterious frontier. Each new discovery about Pluto gives us insight into the building blocks of planets, the chemistry of distant exoplanets, and the processes that shaped the early solar system. Pluto is no longer a forgotten remnant cast aside when it lost its planetary status. It is a natural laboratory, showing us that planetary activity, atmospheres, and even oceans may exist in the most unlikely places. If such complexity is possible here, at the edge of the Sun's reach, then the potential for habitable worlds elsewhere in the galaxy grows exponentially. Could tiny organisms really be swimming in Pluto's hidden ocean? Could the chemistry taking place under its icy shell echo the processes that seeded life on Earth? Or even mirror what may be happening on planets circling distant stars? An unfinished story. The answers lie locked beneath layers of nitrogen ice and frozen mountains, waiting for us to uncover them. Pluto's surface and atmosphere whisper of processes that remain mysterious, hinting that it still has secrets to reveal. What we do know is this: Pluto's story is far from finished. Once dismissed as a frozen rock, it has emerged as a world of complexity, change, and tantalizing possibilities. It challenges our assumptions, fuels our imagination, and proves that the universe never ceases to surprise us. Perhaps the greatest lesson Pluto offers is simple yet profound. Never underestimate the overlooked, the distant, or the forgotten. In the coldest corners of space, life and wonder may still be waiting.